Welcome to this video on the topic of simultaneous equations. In this video we're going to go over two concepts. The first one being what is a simultaneous equation, and then secondly we're going to have a look at how we can solve simultaneous equations using a method called substitution. Now jumping straight into it, the first question is what is a simultaneous equation? And the best place to start is what's not a simultaneous equation. Now what we can see at the top of the screen here is that we've got two equations, 3x plus 4 all over 5 equals 2 and y over 2 minus 3 equals minus 1. Now what you'll notice is that in both of these equations there's a singular unknown and they're linear equations as well, in that we can rearrange both of these equations such that each of the unknowns has a definitive value. So in the first case x is equal to 2 and always equal to 2, and y is equal to 1 and y is always equal to 1. These equations are not related to one another and thus they do not impact each other. Now imagine that we have something slightly different, not quite a simultaneous equation, but we've got a linear equation but it involves two unknowns. So we've got y and we have x. Now because we've got two unknowns here, it doesn't matter however we write it, whichever way we put the terms around. So y equals x plus 1, y is always going to be in terms of x, and similarly x is always going to be in terms of y. We would label this as our first equation here. Now imagine that we have a second equation that's related to the first equation, but it's got slightly different values in it. What we have here is a system of equations, system of related equations. We call this sort of relationship a simultaneous equation, in that we have more than one unknown and more than one equation. Now, if you find that you have as many unique equations or as many related equations as you do unknowns, what you can do is you can find the exact value of all of the unknowns within the equation. Now, the way in which we're going to do that is using a method called substitution. There are actually a few methods in which we can do it, but we'll cover those in later videos. So the first method of substitution, if we're trying to find the values of x and y in this system of equations, is we start off with, say, the first equation, y equals x plus 1. I'm just going to write 1 next to it, so I remember that's equation 1. Then I'm going to get equation 2, and I'm going to write but x equals 2. And what I'm effectively going to do is I'm going to substitute equation 2 into equation 1. So collapsing two equations into a singular equation. So I'm going to write y equals, and every time I see x I'm going to write 2 because that's the value of x, plus 1. Then I'm going to solve, so that's 3. In this case y equals 3. So that's our first value there. Now if we want to check that that's actually true, what we can do is we can grab our first equation again, go y equals x plus 1, rearrange it in terms of x. So we're still in equation 1 here. Then I'm going to say but y is equal to 3. So it's 3 minus 1, and therefore x is equal to 2, which is the same value that we were given at the beginning. So everything agrees here. X is equal to 2 and y is equal to 3. So we see that the variables have a definitive value when we have an equal amount of variables to an equal amount of simultaneous equations or equal amount of related equations. Now this example is quite trivial in that we're simply given the value of x and told to solve for y. What happens when we have a set of equations or a system of equations where there's more than one variable in each of the equations? And the answer to that is we just do exactly the same. So we label both equations And then we need to pick an equation to work with. Now, when picking an equation to start off with, you want to go with the equation that will give you the least resistance. Now, looking at this, in the first equation here, y is already the subject, so this would be a really good equation to use as the substitution equation, and this one would be good for the start. So I'm going to go with equation 2, 3x minus y equals 1. Just label it 2 there so I know what I'm doing. Then I'm going to say but y equals x plus 5. Then we go 3x, take, and I'm going to throw in some brackets because every time I see y, I'm going to write this expression here, x plus 5. And on the right hand side, we're still equal to 1. Okay, now expanding the brackets, minus x minus 5. Now I'm going to collect like terms. 3x minus x, that's 2x. Minus 5 equals 1. Moving the constants to the right hand side, we get plus 6. And therefore solving for x, so dividing both sides by 2, we find that x is equal to 3. Nice and easy. Alright, that's our first variable done. Let's go in for the kill and get our second variable. So we need to start off with the equation that's going to provide the path of least resistance. In this case, it's number 1 again. So y equals x plus 5. It's equation 1. Then we're going to say but x equals 3. Therefore, whenever we see the value of x, we replace it with 3. Plus 5, still y. Evaluating, y is equal to 8. Done. Now if we want to verify that we did everything correct, then we can jump back over and we can go y equals x plus 5. And then we can say but y equals 8. 8 equals x plus 5. And then rearranging, x is still equal to 3. So over here, that's just verifying. You don't have to do that step. So that's the first example of how we do substitution in a set or a system of equations with more than one variable in both of the equations. Now let's consolidate that knowledge and do one more. We'll go 4x plus 3y equals 2. And then our second equation, x equals 8 plus 3y. First thing I'm going to do is I'm going to label both of these equations because it's really important to show the working out and show how it's all done in a readable way. Now, the second step is we have to think about what equation do we want to start with and what one do we want to use as the substitution equation. Now, the second equation here, x equals 8 plus 3y, this would be a really good substitution one because it's already got the equation's already rearranged such that x is the subject. And in equation 1, it's not that case. So we'll start off with equation 1, like so. And then we'll substitute equation 2 into equation 1. Of course, I need to label these. So we're going to go 4. Then we open up some brackets. And we throw in the value of x. So it's 8 plus 3y. Tidying up the brackets, 4 times 8 is 32. 4 times 3 is 12. All of that's still equal to 2. Collecting like terms, there's a 15y. There's a 32. There's a 2. Moving the constants to the right hand side. Just have 15y on the left, minus 30 on the right. And dividing both sides by 15, we get y is equal to minus 2. Going in for the kill, we start off with equation 2 now because it's rearranged in terms of x, so nice and easy for us to work with. Then we're going to say but y equals minus 2. Therefore x is equal to 2. Too easy.